Hello everyone. Let us see the another reagent which is used for the oxidation of olefin to the diol, osmium tetroxide. This is a reagent which is used to convert the olefin into a syn diol or syn dihydroxylation. So one reagent or each reagent of osmium tetroxide will add two CO bonds to the C double bond C in syn fashion. This reagent is very toxic and it is volatile, but it is a reliable method to form a syn diol. When alkene is treated with osmium tetroxide, it will give you an cyclic osmate ester. This is the cyclic osmate ester, which upon hydrolysis or reduction with hydrogen sulfide, sodium bisulfate or sodium sulfide produces cis-1,2 diol. Now the another thing, this reaction is stereospecific. Now why it is specific? Because when E-alkene is treated with osmium tetroxide, it will give you syn diol, and when Z-alkene is treated with osmium tetroxide, it will give anti-diol. Now this is the example where this is a transalkene which is an E-alkene. When treated with osmium tetroxide, it will give syn diol as mentioned earlier, and when the cis-alkene or Z-alkene is treated with osmium tetroxide, it will give anti-diol. Now what is the regioselectivity of this reagent? The regioselectivity is it will oxidize the electron rich double bond, and it is always attack from the less hindered side. So if this is the example, you can observe that this is the double bond where this osmium tetroxide is adding from this side, because here there is a methyl group, so it will add from the opposite side, less hindered side, and it will give you diol. This is most widely used with a co-oxidant, and the most widely used co-oxidant along with this osmium tetroxide is NMO, which is N-methyl morpholine N oxide. N-methyl morpholine N oxide. So this is what the co-oxidant which is used with OsO4. Now this is one example where you have an alkene. Very catalytic amount of OsO4 is required when you are using this NMO, which is a co-oxidant. And then there is a oxidation of this olefin to the diol. Now as it is mentioned that catalytic amount of OsO4 is required, and we know that OsO4 is toxic and volatile, that's why the toxicity of the reaction will be controlled by using the co-oxidants, and very catalytic amount of this OsO4 is required. So always NMO is used in excess and we'll get this reaction. Now instead of NMO, there are other co-oxidants are also there. Some of them are mentioned here: trimethylene amine N oxide, tertiary butyl hydroperoxide, potassium ferrocyanide or potassium carbonate. Now see some of the examples of OsO4 in a catalytic amount. We have seen here the co-oxidants are also used along with OsO4. So this is the one example where again you can see this is side where there is more steric hindrance, the OsO4 will be attacked from the side where there is less steric hindrance. So you'll get a diol. And then the chemoselectivity, basically the chemoselectivity means which group will react. So there are two alkene, one is the triple bonded and the another one is in the form of double bond. So when we use again oxidants and co-oxidants, that is oxidant OsO4 and co-oxidant is NMO, the double bond is having more reactivity towards oxidation and it will give you a diol, which is syn addition. Now here there is a comparison where the alkene has been used. This is a cyclic structure where we have an olefin, and on one side it is treated with iodine in water molecule. Water is there, so this will be Woodward hydroxylation, and Woodward hydroxylation will always give you a syn product, syn diol. We have seen it earlier. And the another reaction condition on the same olefin is OsO4, which will again give you syn addition of this diol, formation of diol. So the difference is that here the hydroxylation takes place, dihydroxylation takes place from the more hindered side, from the more hindered phase, and here the dihydroxylation takes place from the less hindered side. This is one more example. A trans alkene has taken and it is treated with OsO4. So we have seen the trans alkene, if we use, we'll get syn product, and when the same trans alkene is treated with MCPBA in NaOH, it will give you anti dihydroxylation or diol, anti-diol. So this is about the osmium tetroxide.